Population Biology and Human Populations Part 4 will review the calculation of natural increase rate and doubling time from crude birth rate and crude death rate data. Then I will introduce the term total fertility rate and then examine age-gender population pyramids. The significant ideas are a variety of models and indicators are employed to quantify population dynamics. Human population growth rates are impacted by a complex range of changing factors. Here is an outline of all the movies available for population biology and human populations. Use this outline to find the movie you need for review. This movie is focused here. The nature of exponential growth in human populations rests on a positive natural increase rate, the multiplier in exponential growth. Because crude birth rates are greater than crude death rates, as an average of all populations across the globe, the world's natural increase rate is positive, and the global human population grows exponentially. You can see that the world population reached 6 billion in 1999, and then 7 billion in 2012, and will reach 8 billion in 2024. It appears that we're adding 1 billion new people to the world every 12 to 13 years. But notice how the slope of the curve is changing. Growth is slowing. The world's average natural increase rate, while positive through here, is decreasing. Thus, this model would predict increasing from 8 to 9 billion in 24 years rather than 12 to 13. In this graph, the time scale on the x-axis is expanded over a greater period of time, a scale that emphasizes the dramatic nature of our recent exponential growth. Humans, unlike other species in nature, have been able to increase their food supply using hybrid seeds, fertilizers, and irrigation techniques. Humans have eliminated many competitor species to increase the amount of land under cultivation for food. Humans have increased water availability by drilling for groundwater. Humans have reduced the effects of disease through vaccines and cures, such as penicillin. Global human population has followed a rapid growth curve, but there is uncertainty as to how this may be changing. The population growth curves that project into the future are models of potential change in the size of the human population. In this graph, if fertility were to remain high, the population could soar above 14 billion. However, we are observing declining natural increase rates in many less economically developed countries around the world. Thus, it's fair to assume that fertility rates will be medium and the world population, will reach 9 billion by 2050. The strength of this graph as a model results from the three projections based on the manipulation of a variable, fertility. A weakness is the lack of quantitative information on fertility. Fertility is given in general terms, high, medium, and low. Here is the relevant IB syllabus statement that you've seen before. Calculate and explain from given data the values of crude birth rate, crude death rate, total fertility rate, doubling time, and natural increase rate. While we've looked at aspects of this statement before, I will strengthen it here with use of examples from human populations. Remember that the change in the size in the population over time is a function of natural increase rate and n, the population size. NIR, natural increase rate, is the multiplier in exponential growth, and as long as it remains positive, the population is growing exponentially. So here is our first problem, calculating the natural increase rate of India with a crude birth rate of 21 per thousand and a crude death rate of 8 per thousand. You can turn the movie off now and practice how to calculate natural increase rate, or you can follow along with me. I've transformed the crude birth rate into decimal form, the crude death rate into decimal form. I've subtracted to get the decimal form of natural increase rate, 0.013. The natural increase rate as a percent times 100 is 1.3%. We can calculate the change in the size of the population, given that India is 1 billion plus, The natural increase rate in decimal form times 1 billion means that India is adding 13 million new individuals to the population each year. Let's calculate doubling time using the 70 rule. We can calculate the doubling time of India using the 70 rule. 70 is divided by the natural increase rate in percent terms, and it gives us a doubling time of 54 years. If India continues to grow at 1.3%, India will have 2.4 billion people before the year 2070. Now don't worry, India's natural increase rate will surely decline over the next decade. Here's our second problem, calculating the natural increase rate of Sweden. The crude birth rate is 11.8 per thousand. Crude death rate is 9.3 per thousand. You can turn the movie off now, practice calculating the natural increase rate, or you can follow along with me. I've transformed the crude birth rate into decimal form, the crude death rate into decimal form, subtracted to get the decimal form of the natural increase rate, multiplied by 100 to get 0.3% growth. We can calculate the change in the size of Sweden as the population is about 10 million people. So 0.003, the natural increase rate in decimal form, times 10 million people gives us 30,000 new Swedes each year. We can calculate the doubling time using the 70 rule. We can calculate the doubling time of Sweden using the 70 rule. 70 divided by the natural increase rate in percent terms gives us a doubling time of 233 years. You can see how important it is for populations to reduce the natural increase rate in order to stabilize population growth rate. While the natural increase rate is defined as crude birth rate minus crude death rate times 100 for the percent form of natural increase rate, total fertility rate is defined as the average number of children women in a population give birth to over their lifetime. Now, natural increase rate and total fertility rate are two measures that help us understand how the demographics of a population are changing. A TFR of 2 is theoretically replacement or zero population growth. Theoretically, a TFR of 2 would equal 0 natural increase rate. In this table, you can see demographic data for 5 countries, and as you can see in this table, there is a general correlation between natural increase rate and TFR. Countries with low natural increase rates also have low total fertility rates. Compare India and Kenya, both with high natural increase rates and high total fertility rates, and compare those two countries to the US and China, both of which have low natural increase rates and low total fertility rates. Now keep in mind that a TFR lower than 2 indicates a country whose population would be declining, getting smaller. As you can see with Germany, the natural increase rate is negative and the TFR is well below the replacement value of 2 children per woman. But how is it possible that if the natural increase rate is positive, the TFR could be lower than replacement? How is that possible? Lower than 2, such as China? Well, don't dwell on the small discrepancies between natural increase rate and total fertility rate, though I can explain the discrepancy if you ask in class. Instead, focus on the larger patterns. But also keep in mind that each country is unique, with various factors influencing natural increase rate and total fertility rate differently, such as immigration or emigration, just by way of example. Both of these factors play a role in natural increase rate, but not total fertility rate. Another model of population demographics is the age-gender pyramid. Age-gender pyramids display the number of individuals in 5-year cohorts divided by percent female and percent male. But there's more information here when one considers the broader groups: the pre-reproductive group, the reproductive group, and the post-reproductive group. The reproductive cohort is responsible for producing the reproductive cohort. In other words, this group gave birth to this group recently. And notice the magnitude of the pre-reproductive cohort in this pyramid. The shape of this pyramid with the pre-reproductive cohort larger than the reproductive cohort indicates a country of relatively fast growth. Here are the relevant IB syllabus statements. Age-gender pyramids can be useful in the prediction of human population growth. Analyze age-gender pyramids. Here's another age-gender pyramid. We can see the percent male, percent female, and 5-year cohorts represented by these bars. Now, this pyramid displays approximately equal size reproductive and pre-reproductive cohorts. This is a population of low growth to no growth. The pyramid takes on a slender shape overall. The sides are roughly of equal magnitude for females and males all the way up through the post-reproductive cohort. Now, the top of all pyramids tapers as such because we reach our biological limit. We reach death. One last thing, notice that there are slight bulges in the pyramids, like we can see. These bulges can be explained with a close examination of events within the country, changes in population policy at the government level, changes in culture, changes in economics, changes in political events such as conflict. In this slide, we can see an age-gender pyramid where the pre-reproductive cohort is much larger than the reproductive cohort, indicating fast growth. In the middle image, the population growth rate is slowing as the difference between the pre-reproductive cohort and the reproductive cohort is less than it is for the population on the left. And lastly, on the far right, with nearly straight sides, we have an age-gender pyramid with all the cohorts being approximately equal in size. We can see a country of low to no growth, replacement level conditions, a TFR of 2. And age-gender pyramids can display a country in negative growth. As you can see on the far right here, the reproductive cohort is having children below replacement level, so it's a group that's larger than the pre-reproductive cohort. Many developed countries, more economically developed countries, especially in Europe, have age-gender pyramids, such as this one. These age-gender pyramids nicely show the percent males and percent females in 5-year cohorts in each France and India. France displays a slow to no growth demographic, while India displays fast growth. When a less economically developed country, like India, has a huge pre-reproductive cohort, the country will not stop growing for another 20 plus years, even if the government implemented replacement level policies today. In other words, even if the TFR of India was fixed at 2 from today on, the country will grow because the pre-reproductive cohort will grow up to become the reproductive cohort, even if they only replace themselves. Thus, if this large cohort simply grows older and replaces themselves, the population will grow. As one last note, in France, the low number of males 65 and older may represent the impact of World War II. In this slide, we can see 2 age-gender pyramids. On the left, one for a less economically developed country, and on the right for a more economically developed country. In the age-gender pyramid on the left, we can see that in 1985, the population was growing rapidly, as indicated by the strongly pyramidal shape of the age-gender pyramid and the relatively large pre-reproductive cohort relative to the reproductive cohort. Now, as this country developed policies to slow growth, the pre-reproductive cohort grows older to become the reproductive cohort. The population grows larger for another 20 to 30 years as this large base begins to occupy this position in the pyramid. In 2025, the sides of the pyramid are more vertical. With population policies, the TFR is declining towards 2. The cohorts are just replacing themselves, and so the numbers across the cohorts become more similar. In the same 20 to 30 year time period, the more economically developed country did not have much dramatic change in its age-gender pyramid. As I mentioned earlier, age-gender pyramids can display some unusual cohorts that appear to bulge from the pyramid. In this image, we can see the demographic change in the U.S. shortly after the Second World War, known as the baby boom. The euphoria following the end of the war, along with economic growth, spawned a boom in new babies, and the demographic bulge can be seen here as the baby boom cohort ages over time. A large number of people in the post-reproductive cohort, as you can see here, is known as a graying of the population, and this has certain implications for the country. If the gray cohort is larger than the reproductive cohort, there is an economic strain on the country because older people who are not working require high levels of social and medical services that must be paid for by those who work and pay taxes. In other words, if the number of individuals working, providing tax revenue to the country, is smaller than those not working, those who need government services, there's a budget problem. Here are interesting age-sex pyramids showing Germany and Turkey. Emigration from Turkey, particularly by males, can be seen in this odd shape of the Turkey pyramid. Germany has been the recipient of immigrants from Turkey, and this can be seen here in the age-sex pyramid of Germany. Immigration and emigration has various causes, but principal among them is economic opportunity and conflict. People want economic opportunity, and they relocate to places where there is more opportunity. As well, people move to avoid political or religious conflict. Migrants bring skills and an interest in working, both of which stimulate the economy of the recipient country. As well, migrants bring cultural diversity to a location. Migrants also place certain demands on their new land, for example, health services, educational institutions, and these can be strained with the arrival of immigrants. And lastly, migrants, by virtue of their unique culture, could increase social conflict within a new country where the culture is different. This is a slide to prompt you to think about the factors that influence the natural increase rate in human populations. The factors that influence the natural increase rate in human populations are far more complex than those that influence the natural increase rate in wild populations. Now, in this slide, I've not included the biological factors, the internal factors, that would regulate wild species, such as clutch size or age of reproductive maturity and number of reproductive episodes. The internal factors are not important in human populations, but the important factors influencing the natural increase rate in human populations are the economic, political, and cultural factors that specifically influence birth rates. The economic, political, and cultural factors that influence birth rates will be the subject of the next movie, but maybe you can already name a few of these factors. The external factors, such as food, water, and disease, remain important in the growth or decline of local human populations. These external factors would be the density-dependent factors and density-independent factors. This graph shows world population over time. It shows the growth in the world population from 1750 to 2150. And a large component of the exponential growth of human populations over the last 50 years has been the growth in the developing world. The economic, political, and cultural factors that influence birth rates have been most apparent in less economically developed countries. Here are some of the economic, political, cultural, historical, and religious factors that influence the birth rates in human populations. Opportunities for women in education or employment, birth control access or understanding of how to use birth control, Social Security provision for the elderly. Do the elderly need children to provide for them in old age? Children involved in the labor pool. In agricultural communities, children often provide a needed labor pool. Age of marriage. In some cultures, the accepted age at marriage is less than in other cultures. Preference for male children. Some cultures have a preference for boys, and this influences medical practices. Religion. Some religious leaders speak out against the use of birth control. Almost immediately, you can see why less economically developed countries have been most responsible for the increase in the world's population over the last 50 years. And that brings us to the end of Population Biology and Human Populations Part 4. In Part 5, we will take a close look at the most important factors influencing birth rates in human populations.